Hi and welcome. I am trying to learn particle physics. Today beta decay and Paritysymmetry, and after we've done it we're gonna do martial arts basic training. If you participate in the martial arts basic training, then it's die Augen. Now what do we have here written to beta decay? We already did it in previous parts, but I want to go back to these two subjects. Of the four known fundamental forces, the weak nuclear force has the least obvious purpose. Its effect was first discovered at the turn of the 20th century in the place where it is most obvious at work. In radioactive beta decay. We just want to say how much, just what we know about beta decay. It's not much, but we want to have at least a little bit. And we can build up onto it. It's not particle physics or chemistry. In the most common form of this decay, so beta decay, radioactive beta decay, beta minus decay, is a neutron decaying into a proton and also spitting out a negatively charged electron, that is to conserve electric charge. I don't know what that sentence really means. To conserve electric charge, it is there's a proton that's positive and the electron is negative. It was a neutron, so it should not become positive. It makes sense. How should the neutron become positive? But I don't really know what it is meant with conserve electric charge. Beta plus decay does the reverse and turns protons into neutrons. A proton, a positive one, decays into a neutron. Does give up also an electron. It would mean that a positive proton becomes a neutron. It is logically only possible if an electron splits out. But how can come out of a proton an electron? How can come out of a neutron an electron and a proton? Why are things decaying in the first place? This amounts to an ability unique to the weak nuclear force to change flavor for quarks that make up protons and neutrons. For example, switching a down quark to an up quark or vice versa in beta decay. A down quark to an up quark. We're going to make it short. Only what we know here. Beta minus decay, a neutron decays into a proton and also spits out a negatively charged electron to conserve the electric charge. Beta plus decay is the reverse thing. Protons are turned into neutrons. We're just gonna let our missing thing what happens now exactly there, but we have at least a way. Now, according to what will it be, we did already a part of what it was. Richard Webb. Editor Richard Webb. Abigail Beale, additional editing. Publisher Nina Wright. Editor-in-Chief Emily Wilson. We're going to say Richard Webb. Richard Webb's essential date? Particle physics understanding reality building block? We're going to say that thing. I don't know what it means. Particle physics understanding reality's building blocks by Richard Webb. Page 32. Beta minus decay. We're starting with minus. Beta minus decay. A neutron decays into a proton and spits off to reserve away conserve electric charge, a neutron, an electron, and the beta plus decay is the opposite, is the reverse. Beta plus is the reverse. Protons are turned into neutrons. I'm going to stop a second camera. Beta minus and beta plus decay. Beta minus decay is the neutron. What is it called? Decay. Beta minus and beta plus decay. Beta minus decay is a neutron decaying into a proton and to conserve the electric charge also spitting out a negatively charged electron. And beta plus decay does the reverse. A proton turns into a neutron. And that is according to Richard Webb's Particle Physics Understanding Reality's Building Blocks, page 32. Now I'm going to stop the camera. And what are we even doing as fitness? We're doing martial arts basic training. So we're having around 3 minutes, but I don't know if it's enough for going through it. So it's enough for the title, for the Paritysymmetry. It was investigations of a weak force by Chinese-American physicist Qian-Xiong Wu that provided one of the most profound demonstrations of the importance of broken symmetries and particle interactions. One of the most basic symmetries we know of is mirror symmetry. In particle physics, this goes by the name of Paritysymmetry, a principle that says particle processes, collisions, decays, should happen in the same way if all the positions and orientations of the particles involved are flipped in the mirror. In 1956, theorists Sung Dao Li and Yang Chen-Ning showed that paritysymmetry was valid for the interactions involving electromagnetism and the strong nuclear force, but they found no evidence for it holding in interactions involving the weak nuclear force. Our times are too short to make decisions like, do we add when we say that Qian-Xiong Wu did make an experiment to prove it, or that Sung Dao Li and Yang Chen-Ning prognosed it, theoretically. In a way, what? In 1956, Qian-Xiong Wu designed and built an experiment at the US National Bureau of Standards in Maryland to test Li and Yang's idea by looking at the directions in which cobalt-60 atoms trapped in the magnetic field emitted beta decay products. And she found asymmetry, the weak interactions, the weak what weak? Weak nuclear force. Did not happen. Okay, and where we have it, and I think we're going to do 2 videos. Mirror symmetry and paritysymmetry. Mirror symmetry says we will be way better to remember it if we do it just a second time. Even if we are now able to do it in 1 or 2 minutes, why should we do it? Now, what are we going to do? We can prepare a downtime. Mirror symmetry is the principle in science. What is here? One of the most basic symmetries we know of is mirror symmetry. Okay, mirror symmetry means that if something is in the same way, all the same build up another time, all the same will happen the same way. Will we understand that correctly? It's a bit much got from a few lines. One of the most basic symmetries we know of is mirror symmetry. In particle physics, this goes by the name of paritysymmetry. A principle that says particle process, we're going to add that maybe, particle processes, collisions, decays should happen in the same way if all the positions and orientations of the particles involved are flipped into the mirror. I think we can shorten it down. If it turns out if we're wrong, we're going to learn more with the mirror symmetry, so what I just said. But if all the things are built up the same way, that it happens then in exactly the same way again. Paritysymmetry is, in particle physics, the mirror symmetry called in particle physics. That means when all the particles with same orientation, all the same, are built up again, they decaying and collide exactly the same way. And it was found out that regarding the electromagnetism and electromagnetism force and the strong nuclear force, that is true. But the weak nuclear force interacts not the same, even with completely the same setup. 1956 did Sung Dao Li and Yang Chen-Ning prognosed it, and it was then actually proven in the same year by Qian-Xiong Wu, where she took cooled cobalt-60 atoms, put them into an electromagnetic field, and when looking at the directions of the decaying products, it was then actually found out that the weak nuclear force is not reacting all the time the same. But the beta decay, when the neutrons are turning into the protons, or the protons into the neutrons in this beta decay. So there are different types of decay. But when they're decaying, but what? Decaying, I don't know what I wanted to say. With the weak nuclear force is not the same. Now, what we will do in the next part, we will do maybe, if we dare, the mirror symmetry or just the Paritysymmetry video. That means, if you were here for particle physics, you can go directly to the next part of particle physics where we continue Paritysymmetry. If you stay and participate in the martial arts basic training, then it's better the honors. We're bringing one foot up and we're bringing one leg up and we're putting the foot down. We're bringing the foot up and down and up and down. And the other leg up and bring the foot up and down. And now go to the side. And those are pointing forward and we're stepping inside. And over to the other side. Again, toes are pointing forward and we're stretching the inner side. And now, martial arts basic training. So we're doing momentous first. So again, into, I don't know what it's called in English. And over to one side and to the other side. Momentous. And now the lunges, we are going with the front. And back. And again the front. And back. Two more. And now to the shovel snow plow. Bring one knee up, bring it back, making 3 steps. Our leg up and back. Knee up and back. 1, 2, 3. Knee up and back. Up, back, and last time. And, stretch kicks. Arm out, kick against it. 2, 3 steps. Arm out and kick against it. And now the frog. Knee up and back and in. Up and back and up and in. Okay, that was enough. Now stretch kicks. Crescent kicks. Kick out and upper leg. Up, back, up, in, up, back. And now lunge kicks. So I'm going to kick now close to the camera. Go in front, and again back. And again in front with the other leg. Kick, and back. Lunge in front, go down with the knee, and kick in front. And again back. Right leg first, and kick with the left foot, and back again. And the left leg first, down into the lunge, kick in front. And now squat kicks. Go down into squat, up, kick to the side. You can do a wider squat, up, to the side, down, and kick, down, kick. And the last 2. And 2 with swing kicks. Swing in front, over. You can do 3 steps, or you swing directly, and swing. And again 3 steps, swing, and over. 1, 2, 3, swing, over. And now some push-ups. Let's stop to that. The arms underneath the shoulders and the elbows close to the rib cage. This was the first one, the second one, the third one, and fourth one. And we're already at number 6, and now to the number 7 and 8, and now 9 and 10, and it's the last 2, 11 and 12. And now just with stretching, like a sit-up stretch. In onto the ground and pull the toes in. Put to the left and pull the toes in. Put to the right and pull the toes in. To the middle and move the leg from left to right. Over here onto the ground. Pull the toes in. Put to the right and pull the toes in. Into the middle and pull the toes in. Left and pull the toes in. Now to the middle and move the leg from left to right. Let's do it stretching. Knee up. Point the foot down. Knee up. Point the foot down. Legs to the side, breathing out, and breathe out. in and out. Breathing out, relaxing. And breathing out. That was the martial arts basic training. I think we will do it next time.